Hi friends, welcome back. We are studying Advanced Java Programming. In the previous lecture, we have completed unit number 4. Now, in this current lecture, we are going to study unit number 5, Interacting with Database. It has hours 8 marks 12. In this first lecture of unit number 5, Introduction to JDBC ODBC. First point, Java as a database front end. Java offers several benefits to the developer creating a front-end application for a database server. Java is write once, run everywhere language. This means that Java programs may be developed without recompilation, deployed without recompilation on any computer architectures and operating systems that processes a Java virtual machine. The operating system must possess the Java virtual machine, then this can work. In addition, there is a cost associated with deployment and maintenance of the hardware and software of any system that is client. The corporation owns systems such as Windows PC, Macintosh and Unix desktop-centric clients, FAT clients, can cost corporations between $10,000 to $15,000 per installation seat. Java technology has made it possible for any company to use smaller system footprint. These systems are based on Java chipset and run any and all Java programs from built-in Java operating system. Java-based clients that are thin clients that operate with minimum of hardware resources yet run the complete Java environment are expected to cost around only $70 per seat. According to studies, saving for the corporations moving 10,000 fat clients to thin client systems could be much as a 100 million annually. There are many industry strength DBMS available in the market. These include Oracle, DB2, Sybase and many other popular brands. The challenge to Sun Microsystems faced in the late 1990s was to develop a way for Java developer to write a high-level code that accesses all popular DBMSs. The Sun Microsystem made the challenge in 1996 with the creation of JDBC driver for JDBC API. Both were created out of necessity because until then Java wasn't industrial strength programming language. Since Java was unable to access the DBMS, the JDBC driver developed by Sun wasn't driver at all. It was specification that described the detailed functionality of JDBC driver. DBMS manufacturers in the market and third-party vendors encouraged to build JDBC drivers that conformed to Sun's specifications. Those firms that build JDBC drivers for their product could tap into growing Java applications market. The specifications required a JDBC driver to be a translator that converted low-level proprietary DBMS messages to low-level messages understood by JDBC API and vice versa. This meant that Java programmer could use high-level Java data objects defined in the JDBC API to write a routine that interacted with the DBMS. Java data objects convert the routine into low-level message that conform to the JDBC driver specification and send them to the JDBC driver. The JDBC driver translates the routine into low-level messages that understood and processed by DBMS. This way JDBC can work. Next point, the database client server methodology. Relational databases are the most common DBMS. A main characteristics of a relational database is the absolute separation between physical and logical data. Data is accessed through the associated logical model to avoid supplying physical storage locations and to reduce the limitations imposed by using physical information. The following figure shows the database client server architecture: client 1, client 2, internet, intranet, LAN, MAN, WAN, like this structure, and this Oracle server, Sybase server, like this. This is the client server architecture. Relational databases allows the definition of relations and integrity rules between data sets. F. Cod developed this model at the IBM San Jose Research Lab in the 1970s. The language to handle, define, and control data was also developed at the IBM Lab, that is SQL. SQL stands for Structured Query Language. SQL is a query language that interacts with a DBMS. It allows data access without supplying physical access plans, data retrieval as sets of records, and the performing of complex computations on the data. Next is the software architectures. The first generation of client server architectures is called two-tiered. It contains two active components: the client, which requests data, and the server, which delivers data. Basically, the application's processing is done separately for database queries and updates and for user interface presentations. Usually, the network binds the backend to the front end. Although both tiers could be present on the same hardware. For example, hundreds or thousands of airline seat reservation applications can connect to a central DBMS to request, insert, or modify the data, while the clients process the graphics and data entry validation. The DBMS does all the data processing. Actually, it is inadvisable to overload the database engine with data processing that is irrelevant to the server. Thus, some processing usually also happens on the clients. The typical client server architecture is shown in this figure. Java application, JDBC, client server, client system, and now the database server. Two-tier client server architecture. In these two components are active: client and server. The two tiers are often called as application layer, includes JDBC drivers, business logic, and user interfaces, whereas second layer, that is database layer, consists of RDBMS servers. Its advantages: it is simple in design. Client-side scripting offloads work onto the client. Drawbacks of this system: fat client, it is inflexible. Although the two-tiered architecture is common, another design is starting to appear more frequently. To avoid embedding the application's logic at both the database side and the client side, a third software tier may be inserted. In three-tiered architectures, most of the business logic is frozen in the middle tier. In this architecture, when the business activity or business rules change, only the middleware must be modified. The figures below illustrates the three-tier architecture. In this figure, Java application which is situated on the client side client machine, JDBC drivers, JDBC application is situated on the server, and database server is on the another system on the server side. This is called as the three-tier client server architecture. Advantages: it is flexible. It can change one part without affecting others. It can connect to a different databases without changing code. Specialization, presentation or business logic or data management. It can catch queries. Also, it can implement proxies and firewalls. So it has a vast amounts of advantages. Its drawbacks: higher complexity is there, higher maintenance cost is there, lower network efficiency, more parts to configure and buy. These are the some disadvantages of the three-tier client server architecture. Next point is the what is JDBC. Up till now we have considered JDBC, but what is that? The JDBC stands for Java Database Connectivity. What is this? JDBC, besides a nifty acronym, it refers to several things depending on context. Its specification for using data sources in Java applets and applications. It's an API for using low-level JDBC drivers. It's an API for creating the low-level JDBC drivers which do the actual connecting, transacting with data sources. It's based on the Open SQL Call Level Interface (CLI) that defines how client-server interactions are implemented for database systems, and all these forms the JDBC. JDBC is an API for using low-level JDBC drivers for data sources, for creating the low-level JDBC drivers, and also for the Open SQL Call Level Interface, like this. The JDBC defines every aspect of making data-aware Java applications and applets. The low-level JDBC drivers perform the database-specific translation to the high-level JDBC interface. This interface is used by the developer, so he doesn't need to worry about the database-specific syntax when connecting to and querying different databases. The JDBC is a package much like other Java packages such as java.awt. It's not currently a part of the standard Java Developer Kit JDK distribution, but it is slated to be included as a standard part of the general Java API as the java.sql package. Soon after its official incorporation into the JDK and Java API, it will also become a standard package in Java enabled web browsers. Though there is no definite time frame for this inclusion, the exciting aspect of JDBC is that the drivers necessary for connection to their respective databases do not require any pre-installation on the clients. A JDBC driver can be downloaded along with an applet. The JDBC project was started in January of 1996 and the specification was frozen in June of 1996. JavaSoft sought the input of industry database vendors so that the JDBC would be as widely accepted as possible when it was ready for release. And as we can see from this list of vendors who have already endorsed the JDBC, it's sure to be widely accepted by software industry, and these are the some software industries which are widely using JDBC: Borland International, Bulletproof, Cyber SQL Corporation, Data Ramp, Dharma Systems, Gupta Corporation, IBM's Database 2, DBM, DB2, Imaginary, MSQL, Informix Software, Intersoft, Intersolve, Object Design, Open Horizon, OpenLink Software, Oracle Corporation, Persistence Software, Presence Information Design, ProC, Recital Corporation, Rogue Wave Software, SAS Institute, SCO, Sybase, Symantec, Thunderstone, Vigigenic Software, WebLogic, XDB Systems, list goes on. These are the some industries which are incorporating or using the JDBC, and this list is very vast. The JDBC is heavily based on the ANSI SQL 92 standard, which specifies that a JDBC driver should be SQL 92 entry level compliant to be considered a 100% JDBC compliant driver. This is not to say that a JDBC driver has to be written for an SQL 92 database. A JDBC driver can be written for a legacy database system and still function perfectly. Even though the driver does not implement every single SQL 92 function, it is still a JDBC driver. This flexibility will be a major selling point for developers who are bound to legacy database systems but who still want to extend their client applications. This is the history for the JDBC. What is JDBC? Or all the things we have studied, which are the vendors, which are the developers, which are the users, like this. In the next lecture, we are going to study in detail JDBC. Thank you for watching. Thank you guys.